And let's squish it down to 0.5 on Z. Now watch the sphere and your channel editor. And you'll notice that this wraps up the concept of scaling. And now we can say M sphere get scale, and you get back the actual scale of the object. And we have those three functionalities now. Now the sphere carries a lot more functionality, and if we were to keep coding and add some more changes, I can just reload and make a new one. Now as you notice, every time we run this, every time we run this, we get a new copy. See? Now, we're not doing anything to handle that, and the problem is that you only have one sphere object. Sphere 5, and these are just sort of dead in the water because our code is not doing anything to handle it or clean it up. There are ways that you could sort of watch that, but the idea here is that you're wrapping up the functionality of setting up these spheres. So let's go back and look at some more of our code. So let's open up this Maya Sphere 4. Now this one's going to have a lot of description in it for your benefit to look at later with lots and lots of comment. I'm really trying to put as much comment in here as possible so that you can review this in your own time and retain all this information that that I've set up. But let's take a look at this line by line here. These are just docstring comments. They attach themselves to the stuff you put it under. And this init is still the same. Now here's something that I've added that is not necessarily something you would do in, say, production, but it's a way to show you. I was talking about how the spheres don't clean themselves up, right? So every class has another built-in, like this, called del, and this is for what happens when that object is deleted. Whereas this init is what happens when this new object is set up. This gives us a chance to clean up. So we can override our del method, and we can say self.delete. Well, what is self.delete? Let's scroll down. I defined a method called delete that first says self.exists. If it exists, run the commands to delete itself using its name. And I wrote another method here called exists, which checks if it exists. So you can see I've wrapped up multiple commands module things. Commands object exists, commands delete, and I just wrap that all up into here. And you can see here's the examples of how you can delete. Now let's take a look at what happens here. We've got our new scene. Let's import our new sphere. And let's call it, we'll just do the defaults. Let it name itself 4. Okay, so we've got a sphere. Now the way you can delete, if I have x equals 1, and if I delete x, meaning tell Python to clean up that variable, x no longer exists. Now we can do the same thing with our sphere. Notice that the sphere disappeared when the variable disappeared because we attached the cleanup of the geometry to the cleanup of the variable. Now I'm not recommending you necessarily do this in your production environment. It's more of an example of class functionality. I can make this again, and a better way to do that would be to just call the delete method, because this gives you more control of when you want it to delete. Let's try a little example. Let's try something where we do for I in range 10, and let's say create a sphere and msphere dot set translation x equals I, let's say I divided by 2. Okay, and oh, let's save them too. Let's say spheres equals list spheres dot append m sphere. Okay, let's run this. Oh, let's see. What did I mess up here? So what this is telling us is because the name is default and we're trying to use the same name every time. So let's just say name equals sphere I, so that we make sure each one gets a new name every time, right? So now we've got these spheres that all got made, and they're all part of this list. As you can see, we've got this list of our Maya spheres, right? So if I delete the spheres list, I'm not deleting geometry. If I delete the list, they all go away except for this one that I've selected because it was still in memory. It was the last one that that got created. Oh, sorry here. Yeah, it's the last one that got created. So all the other ones got overwritten, but it's the last one that exists. So if I now delete m sphere, see, this variable is still alive because we did a for loop and we kept overriding sphere, and when the loop finished, sphere still exists. So then we delete that, it goes away too. And so that's just an example of the delete method. I document here that it's not really what you do. You'd want to use this delete method. So let's keep moving down here, and some other things that I overrode. This str method is another built-in. This says what happens with this object when you cast it to a string. If any time you want to treat it like a string, what happens? So let's find out. We have this here. If I say m sphere, we get this Python type printout of what you're looking at. But what if I cast it to a string? Sphere. Now, what's cool about this? Let's take a look. That we're returning the name of the node. So what's great about this is if, say, you were going to pass this into other functions that took, you know, like commands dot, if you were actually doing a commands dot move, you know, or a get attribute or whatever, I can just take the string value of this, and now I've got something that the commands module expects. It turns it from a Python object into a string. So it helps you keep integrating it with the Python modules. And you could say, you know, you could decide, however, as long as you return a string, you can define how to turn it into a string. Now, let's take a look at this method here. And this requires a little more explanation. Up here in the init, something we changed, and let's look at an example of from this one. In the init right here, we explicitly create our sphere. But in our fourth version, we want to kind of generalize this a bit more. We want to just call a create method with the arguments that came in as a dictionary, and we're not expanding this, we're just passing it a straight dictionary in this case. And you'll notice that this has an underscore in front of it. That means a protected variable or function or method, meaning that it's not meant to be called by anyone using this class. Like say in Maya, like we were using these, you wouldn't call create. It's meant to be used internally, and it's a way to separate functionality. When someone's looking at your code, they kind of know that's not meant to be called by you. It's meant to be implemented, and all it does is we just moved the same code down into this create method. And what's nice about that, you'll see towards the bottom, I'll show you. But let's keep moving on here a little bit. We didn't really change anything else except, well, you'll notice that I also have this do transform, which is a protected method. And let's compare it to our previous one here. Look at the repetition of code. And you'll notice this is almost identical to this and this. And all we changed is move, rotate, scale. So instead, look how much simpler this looks. Set translation just calls do transform with the command that it should run and the XYZ, because these attributes don't change. So what this protected method does is it takes the function that should be called and an expected x, y, z attributes, and it takes that exact same code that we had, and the only difference is this line here. When you pass in that function, command scale, it comes in as the function, and then we call it like a function with the value from before, and self.name is the name of the object, and then all the options that we just made. And you can see that you can pass commands around. Like if I do commands.move, you'll see that this is a built-in move method of the module commands. I haven't called it yet. I just have the reference to the function, and you can pass this around just like any other object, which is really cool in Python, that that functions can be just passed around as first-class citizens like that. And so they are also objects. And so I can pass a function in, and it becomes known as function here locally, and I just call that. So you can see it really cleans up the code to just call these do transforms. And now here's where you see some more inheritance. What we were making here, move this over and get the attribute editor. What we're making is a NURB because we didn't specify. That's the default for the sphere command. Let's move this out here like this. Now, what we did is, well, we've defined this whole great structure for creating a sphere. It happens to be a NURB sphere by default. But now let's say we want to make a polysphere. And we want to make a polysphere, and all we have to do is subclass myosphere, which is up here at the top. Make sure we call our init, but we're going to change the default name to polysphere. That's all we're changing here. And then we're going to define a new create method, which instead of calling sphere, calls polysphere. So let's go ahead and try that out. And that's the only difference, but we get all the same functionality along with it. So if I get this down here, actually I'll put it right here, and we'll call this p sphere, and we'll change this to poly. You'll notice that now a polysphere came in. It's a completely different type of geometry in Maya, yet we can treat it the same way. I can still say set the scale. I can get the scale. I can get the name. And it works exactly the same because we just passed the functionality down. And you can see how this can be really great when you get into writing large tools. You get into writing large tools and you build up these libraries of common code, and it kind of teaches you how to segment your code into general stuff. And then we started with Maya geometry, writing base class things, and we progressively added more to a Maya sphere. And then once we had this Maya sphere, we decided we want a new type, and we didn't have to duplicate any code. This could be in a separate file. This could be even a separate developer, user, artist, who is just pulling in from another file and just changing a couple things because they want some specific functionality. So this is called overloading. And we saw how we can, when we develop and we make changes to the code, we can just hit reload. And a key thing to remember is when you import, make sure you import the actual module and not saying, from this module import Maya sphere, because you won't be able to reload that way. Just import the whole module, and it makes it a lot easier just to say reload, and then you can see that it picked up your changes right here. And that pretty much does it for the basic idea of class and inheritance, and hope you picked up something from that. And next what we're going to do is we're going to move on to some more complete scripts that have a lot more functionality, a lot more definition to them. In this section, we're going to look at a larger project. And what we're going to do is we're going to create our own asset importer tool. Now, regardless of Maya having support for some assets, and you know, this is somewhat of a general tool, and I think it really will help to outline a larger structured piece of code. And what it'll also help us do is get into some UI stuff. And I have a lot of documentation in it, and let's just start taking a look at what we have. So in the asset importer directory, we're going to start with this series of code right here. And we're going to start with asset importer 1. And I will show you what we have set up. Now, before we open the code, I've also included this area here called asset library. And in this asset library, what we want to do is have a file system location. It could be anywhere, but we'll keep it here for the project location. And under that, we want to support the concept of either shows or categories, whatever you want to call them, but we'll call them shows in this term, the general show, the war show. And we want to have a structure where in each one of these shows we have assets and then various images for the assets, like this, right? And we want to be able to bring in more assets to our tool, and that's why I have this new assets area here, and these are just some raw assets that we might want to import with their pictures. So we want a tool that can bring these in and let us import them into our scene and give us a view. Now, it won't be 100% complete in every area, but we're going to do enough of it to where you can see what we're getting at. So let's start with asset importer 1. I'm going to bring up my code here. And asset importer 1. Now, I have a lot of documentation in here, but let's go through this bit by bit and see what it does. Right? So we've got our asset importer class, and that's going to be our basic structure. And we're going to define a couple constants. And again, go ahead and pause anytime you need to take a look at the notes that I have here. But a couple constants we're going to start off with is we're going to say, okay, we need to know generally where our asset location is, and the asset location being where is our asset library root directory. So that you could relocate it anywhere. So we have this class level constant, and then we have where is the default image. If an image is not provided, where would the default come from? And then we want to say what's our default show if an asset doesn't have a show. We're going to call it general. You can change that. And then we're going to I'll get into these in a moment, but now you see that I have these assigned to some more variables, and I'm doing that up here only for the purpose of this project to make it easier on you, because you may not have all your Python paths set up and whatnot, and I want it to be pretty straightforward and work for you. So what I did was I created some some file level constants. These are constants that are for the entire module. That anything could access, any class could access. So I'm saying that our project root is going to be, and this is a special way to say, this will tell me the path of the current file we're in. So that's asset importer 1. We're going to use the OS module to get the directory name. So that's the directory of the file. That would put us here. And then we're going to join that together with 2 directories up. So that would take us from here to here. Right? And that's the project root. And then what we want to do is we want to say, okay, the asset root is that directory plus the asset library. So it joins it. So that puts us here. So that's an easy way just to get a relative path, so you don't have to set up Python paths, and I don't want to confuse you. You see down here, you would normally uncomment this, and you could set a full path to your asset library. You don't have to use my special version. And I do the same thing down here. You could uncomment this, a full path to the, let's go ahead and put that like that, full path to your default image, but in my case, I just want to use my relative version. And then down here, what we're going to do is these are going to be some names when we start tagging what's been imported, and these will create some attributes for us on the imported assets. So we're going to get down here, and when we initialize our asset importer, we want to know what the show is, what the root directory of the asset is, which will be the asset location for now, and then we're going to call this set asset root. And what set asset root does, let's see here. Actually, I don't have that set up yet. Let's go ahead and remove that. That's from step 2. Okay, this is just a basic overview of what we're setting up so far. So we've got our init, and when you start laying out these large projects, it's nice to actually just type out the functions you're going to do, and that's pretty much what this is. We need something that can add an asset into the location. We need a way to list assets by show if we want to. And we want a way to load assets into Maya, given a name of an asset or a show. And then down here what I have is another class that we're just going to call asset, and this is just our container for how to define an asset. And we're going to say an asset has a name, an asset has a scene file, an image file, and a show. And with this asset file, then we could import it, load it, view it. So this is the general structure of what we want to start with. And let's look at number 2, step 2. Okay, so now what we're doing is we're going to take that structure and start filling in some of the blanks. Let's see what this structure looks like. So in addition to the add, list, and load, we've added some other stuff, and let's go top to bottom and see what we're doing here. Let's go up to the top here. Okay, so all of this is the same, and now what we're doing is I added another flag for verbose in case we want to print more information as we're doing things. And what I did was I said, let's set the default show to either the show they pass in, or if it's blank, to the default show. And this is a way to do an either-or assignment in Python, I think 2.6 and newer. So what this will do is this will say, okay, if they didn't pass in show, then pull the show from right here. That's how we set our defaults with the constant. And then we do this set asset root. And what I did with set asset root, when I jump down here, is it sets the root level of our asset library. And it's just a fancy way of setting this root directory. But what it's going to do is it's going to make sure it exists. If it doesn't exist, it's going to use os make dirs to make all the directories needed leading up to this root directory. So it's just a fancy way. If we go up to the top, had you just set this, it could exist, it could not exist, but it's a nice way to make sure that that it does exist before you get working on it. And so let's move down. And this is a new concept that I wanted to show you called properties. And what properties are, they're exactly like the way you would use these attributes just by setting self.equals verbose self.verbose equals self.root equals show. But what these do is these are computed properties, meaning that we can actually control how they get set. So I've got one right here that's show dir. And what it does is it returns the root directory plus the current show. So it's a quick, easy way to call show dir. And the way I would use that is if I just said, you know, self.show dir. That's it. That's how I would get it back. But the neat thing about properties is if I tried to assign to this, it would not work, because you can say that this is only readable. Right now this is only a readable property. And this is just a little symbol that says that it's a decorator that says that this function is a property. Here's another property, self.show. Now why did I do this? You saw in the last class example, I just had my variables just straight accessible. But why did I do it like this? Show is actually a hidden attribute, and what we're going to do is we're not going to let them actually access show directly. We just want to make sure that, okay, they can get the show, sure, but if you try to set the show, we want to make sure that it matches a pattern. and I'm using a regular expression right here, and I'm just going to make sure that the show matches the patterns any lowercase letter, any uppercase letter, a dot, an underscore, or a slash. So that could be just no spaces, no funny symbols, just the basic characters to make a show. And it would raise an error if it was not a proper show format. So what this does is, and you can see the syntax here is, this is to make the getter, and these pop-ups are very annoying, aren't they? This is to make the getter, and down here is how you make the setter. So you have def show, and then you have def show again, but you say that this one is actually the setter, and you can take the variable in. So the way you would use this is like this. You would say self.show to get the show, or self.show equals new show, but instead of it working straight on the attribute, it's going to do the computed property. And this brings us to another concept. I know we've got a lot of concepts here. We've got the properties. You've seen regular expression right here, and you can do lots of pattern matching with it. And this is an exception that we're raising. Now this is not a built-in exception. We've actually created an exception down here called importer exception. It doesn't do anything. It inherits from the built-in exception, and what it lets us do is just catch exceptions that are internal to our program, so we can tell the difference between other errors and ones that we generate ourselves. So you don't have to do anything necessarily. You could make more advanced exception classes, but all I'm doing is inheriting from our importer exception. Let me go back up here again. So if the show doesn't match this pattern, then raise our exception, which we could catch if we wanted to. Otherwise, set the show. Alright, so let's go down here and see how we filled in the add asset. So add takes an asset and uses that to import it into the system. So let's see what the first things we do here. We're going to perform some basic checks. We're going to use this isInstance to make sure that the asset they passed in is actually an asset class, because we have our asset class down here. If it's not, raise a type error and say it's not the right type. Then we're going to move down here and we're going to look at the asset and we're going to say asset.scene. If not asset scene or not is file scene. So what this does is this says if they didn't set the scene, or if they did set the scene and it's not a file, that's another exception. And let's take a look at what we've done with our asset down here at the bottom before we go any further. Asset is inheriting from a standard Python dictionary, because we're just going to use a basic dictionary but add some extra checks on top of it. So we can do that. We can extend a dictionary and subclass that and use it the way we want. So we create our init, we make sure to initialize the original dictionary, and then we want to say that there's some default keys. Name, show, scene, image. We say for each of those, set the key to nothing. So no matter what, a fresh asset will have those empty keys. We set, this is a representation which we looked at, actually we looked at str earlier. This is another version. And what this does is, this is how an item is printed. Not when you cast it to a string, but when you just print it back on the screen. This is what the object will look like. And we use this to nicely format all of our items. And this is another way. There's a lot of stuff packed into this, isn't there? There's another way you can do string formatting. You see how I've, instead of doing %s, I've put these variable names inside of these parentheses. And at the end, you can give it a dictionary. And because self is a dictionary, we are inheriting from a dictionary, it will look up all these keys. So that's a really nice way to format strings. It's going to look up all of these and fill in the blanks. And that's how we'll get our representation. And then we go down here and we've got some more properties. We set the getter on how to get the name. The name gets the key, or if it doesn't have the key, it returns nothing. This is the setter. It doesn't do anything fancy except set it as a dictionary. Same with the show, same with the scene. None of this does anything really fancy. It's just a way to nicely set it up.